Hello everyone, we studied the test block in the last class. Today we start to study the performance of the ultrasonic testing system 1. Ultrasonic testing instruments, probes and test blocks constitute the entire ultrasonic testing system, and the performance of the system will directly determine the accuracy and the ultrasonic testing results. Through the learning of this course, I hope to achieve the following teaching objectives. Master the influence of vertical linearity area and horizontal linearity area on test results. Master the influence of dynamic range and sensitivity on dictation results. Any system consists of several independent components. For example, a group is composed of many individuals. Each component has dual attributes. On the one hand, it has independent attributes to ensure that it can complete its own work. On the other hand, it is a member of the whole. It should obey the group and coordinate and command uniformly. The performance of the ultrasonic flow dictation system, including the performance of the ultrasonic flow dictator, the performance of the probe and its combined performance. The quality of performance directly affects the reliability and accuracy of flow dictation results. Therefore, this state has specially promulgated the general technical conditions of Type A pulse reflection ultrasonic flow dictator, a Type A pulse reflection ultrasonic flow dictation system working performance test method, and ultrasonic flow dictation probe performance test method, and other standards. Among them, each technical performance index is clearly stipulated and specific test conditions and methods are specified. Now select its main points to give an introduction. Vertical linearity, that is, linearity of the instrument amplifier. It indicates that the magnitude of the signal voltage received by the probe is proportional to the echo height displayed on the screen. From the perspective of convenient measurement, the vertical linearity can be described by mathematical expressions, where h is the echo height on the display screen. In actual measurement, h is usually changed by the attenuator value delta E, and the measured h is compared with the theoretical value of reflect the vertical linearity deviation. The result is expressed as the sum of the absolute values of the maximum positive deviation and the minimum negative deviation of the wave height. According to the provisions of the standard NBT 4701320015 for qualified instruments, delta E less than 5%. Therefore, the higher the precision of the attenuator, the smaller the vertical linearity area. The specific measurement method is follows. The test method of vertical linearity is as follows. Adjust to 0 and attenuator retains a certain attention margin. Place a straight probe on the CS series test block, align with the 200 by 2 mm flat bottom hole and use a pressing block to maintain constant pressure. Adjust the instrument so that the echo amplitude of the flat bottom hole on the test block is 100% of the full screen height, but not saturated as the starting reference of measurement 0 dB. Fix the gain, GAIN, and other knobs. Adjust the attenuator, attenuate 2 dB each time, and write down the corresponding wave height H until the edge of the flat bottom hole cannot be identified. Find the deviation of all measured wave heights and theoretical wave heights and calculate the vertical linearity area. Horizontal linearity. It is also called time baseline, which indicates that the display value of echo on the time axis is proportional to the detection sound path. The quality of horizontal linearity directly affects the accuracy of defect location. The horizontal linearity test method is shown in figure. Place the straight probe on the IIW test block, aiming at the large flat bottom surface with a thickness of 25 mm. Turn the knobs such as fine adjustment, horizontal, or pulse shift to make the bottom wave B1 to B5 appear 5 times on the display, and align the leading edge of B1 with 2.0 and the leading edge of B5 with 10.0. Record B2, B3, B4 to deviation values A2, A3, and A4 from the horizontal scale values of 4.0, 6.0, and 8.0. Calculate the horizontal linearity area, delta L, equals to maximum absolute value deviation at max 1.8 B times 100%, B equal 10. According to the standard MBT 47031-205 for qualified instruments, delta L less than 1%. Dynamic range. The dynamic range refers to the maximum undistorted output signal amplitude range of the amplifier. Specifically, it is the adjustment amount, delta dB, of the attenuator in the process of reduce the echo height on the fluorescent screen from 100% to the height that it can just be distinguished, which is defined as flow dictation, the dynamic range of the instrument at the given operating frequency of the probe. The test method is to attenuate a wave of high that has just been 100 full of amplitude to the decibel value required for the minimum value that can be recognized, which is dynamic range of the instrument, in this case, is 0. Generally, the CS series test block is used for measurement, and the height of the test block and the size of the defect are subject to the test. A qualified system is generally required with dynamic range greater than 26 dB. Sensitivity. Sensitivity refers to the ability to find the smallest defects. This refers to the combined sensitivity of the instrument and the probe from system, which is generally expressed by the sensitivity margin. The so-called sensitivity margin refers to the dB number of gain that the instrument still retains when the ultrasonic flow dictation system detects a specified ranging, aperture, and high-shaped artificial reflector to obtain echoes. That is, the actual flow detection sensitivity and the highest sensitivity of the instrument, the difference between expressed in dB. According to regulations, the combined sensitivity of qualified products should be greater than 32 dB. Blind spot. The blind spot is the medium distance from the probe side to the defect that can be detected under the specified flow detection sensitivity. It is the combined performance of the instrument and the probe. It characterizes the close-range resolving power of the system. It is due to the fact that the initial pulse has a certain broadband and the blocking phenomenon of the amplifier. As the detection sensitivity increases, the blind area also increases. The test of the blind area is carried out on the blind area test block. The waveform from the dead zone test is shown in the figure. When the echo height of the bottom surface is the flat bottom hole is greater than 50% of the vertical full amplitude of the falsifier screen, and the wave through formed by the front edge of the echo and the back edge of the initial wave should be lower than 10%. Then the distance from the bottom surface of the flat bottom hole to the dictation surface is the size of the blind spot. To sum up, in this lesson, we have learned about vertical linearity, horizontal area concept, dynamic range, sensitivity, blind spot concept, and testing method. There are many contents and knowledge points are relatively fragmented, but they are all related to each other. Review them in time after class. Thank you.